Assalamualaikum viewers, welcome to my channel. In this video, we will discuss that how to design the primer for RT-PCR. But you must know that primer designing is a critical step when setting up your qPCR or reverse transcription qPCR assay. qPCR primer that anneal poorly or to more than one sequence during amplification can adversely affect the quality and reliability of your results. Also, if you are performing a one-step RT-qPCR, the reverse transcriptase will also use the reverse primer to prime the transcription reaction. In this scenario, a poor primer would result in both inefficient reverse transcription and inefficient amplification. So, considering the above discussion, it is well worth spending the time necessary to design good quality qPCR primer. But first, before designing the qPCR primer, you must know the characteristics of primer. That includes the size of the product of the qPCR must be 70 to 200 base pair. The primer size must be 18 to 30 base pair. The minimum annealing temperature must be 60 degrees centigrade and the maximum is 63. The ideal temperature for annealing of primer with the strand is 60 degrees centigrade. The maximum difference between the annealing temperature of forward and reverse primer must be not more than 3 degrees centigrade. Make sure when you are designing the primer that the primer at the 3 end must contain a C or G residue because T or A residue at the 3' end binds more easily to any strand or at a non-specific weight on the DNA. The GC content in the primer must be 40 to 60%. That ensure the maximum product stability. Avoid self-complementarity to decrease the possibility of primer-dimer formation. Ideally, the primer should have a near random mix of nucleotides. Now, pick the best 2 or 3 primers and blast them in ncbi for their sequence specification. There are various tools that are used to design the primer for qPCR. There are online tools as well as the software, but usually I use Primer Premier to design the qPCR primers. How to use this Primer Premier software and design the primer for qPCR? Let's start. You can use the CDS sequence or genomic sequence to design the primer. First, we try to use the CDS sequence of our gene to design the primer for qPCR. So, you need to copy that sequence. Open the Primer Premier. Go to File, New, and which one is your sequence? Our sequence is DNA. So here DNA and now paste. So it gives the option that how you want to paste as that you have copied or is reverse or complemented. So we want to use it as it is. So okay. Now here it gives the option that what you want to know. Either you want to know the which enzyme restriction sites are present in this sequence or which genes motif or family motifs are present in this gene sequence or primer. So we need the primer. So first we want to know how to design the primer, so click the primer. So here are some options that S means sense strand, while A means anti-sense strand. If you want to design the primer on sense strands, then you click on S. The primer that design at this strand will be the forward primer, while the primer of the anti-sense will be the reverse primer. So here are the search that how many primers are you want to design or calculate. So we use this search option. Here it gives the option that what type of primer you want to design, PCR primer or sequencing primer or hybridization probe. So we need the PCR primer, so we click on the PCR primer, and here are the some other options that you only need the sense primer or anti-sense primer, or both are in the form of pair. So we click on the pair, and this is the sense strand length, this is the anti-sense strand length, so it will remain same. But here is the PCR product that you want to design the forward and reverse primer. So what was the PCR product? So we write here 100 to 200, and here is the primer length that what primer length you need. So we here is okay 25 plus minus 2, or you can also change it with 27 like this. So here is you can okay, and then press okay. So it gives us about 57 pair of that primer. So we will check one by one a few. Here is a one is that primer. So when we click on it, so it gives its characteristic that the sense primer starts from the 6 to 7, where its length is 25 and its temperature, annealing temperature is 64.2. This is the GC content. Where the reverse primer is also length and its start position and its annealing temperature GC contents, and this was the product length of this. And here are some that there is a hairpin that was not found in the sense primer, so it is very good, but it is found in the anti-sense primer, so it is not acceptable here. So dimer is also not found in the sense false priming cross dimer. It means that our sense primer is okay, but the anti-sense primer is a little bit not good. So we will also edit it. First we try to edit the sense primer because its temperature is a little bit high. To decrease this temperature, you click on that S and then edit primer. Here you can delete one base and then analyze. So its temperature comes to 60, and here also hairpin is not found, timer is also not found, false priming is not found. It means it's a good primer for us. And now we will try to solve the problem of that anti-sense primer. I want to remove that hairpin or dimer or false priming. You must try your best to remove all these things, but sometimes you are not succeeded to remove this problem, but you try to remove these hairpin as much as possible. So then edit it, so we can or it is no, or here we see. So you can also edit it by clicking this point, this pen point on any base where when you keep it and press, so it will give the characteristics of that primer that becomes. Here you can see one by one. We can check it. Here you see that when we click it on hair, so here the hairpin is removed, but its temperature is a little bit lower. To increase this temperature, so we will add some bases in primer. So it is primer, and then there is a C, and you can add the G and analyze. Its temperature is 60.4, but here the at the 5 prime of the primer is G, and at the 3 prime inside of the primer is C. Here is also chance that they will make the pairing of each other and have the effect on the primer quality to anneal with the strand. So we can change this into another base, like here is a T, here is a, so its complementary is T, and then analyze. So it is also good 62.7 degrees centigrade, and the difference between two primers annealing temperature is not greater than the 3, so it is good, it's okay. Now we will save the primer. How to save? Go to edit, copy, sense primer, open your file, write Q for qPCR, gene name like gene AV01, and its sense primer is forward primer F, and paste. Like for other Q gene 01, and now we will try to copy the reverse primer. So go to primer premier, edit, copy, and antisense. Okay. Now its one primer is ready. Now we will try to find the another primer, because before you testing you need to design 2 or 3 primers, then you will check them that which one is specific to this gene. So here this is another one, so we can click on this, or anyone you can choose. So this one you can see that in this primer the sense is in the form where in the antisense we have something like this other first one, but its temperature is also higher, so we can remove 1 or 2 base pairs. This temperature comes to 60. So now also edit another one. Here is at the 3 prime and it start with A, but if you remember we said that it must start from C or G. So find any G at the strand, it's the G, so click here. We try to remove this hairpin. So if we delete some bases, delete, and then analyze, or another one, analyze, also here. When you are adjusting your primer, so you will also check that what was the product become. Like here when I click it, here, so its product decreases when I go this side. When I go at the right side, so its product size is increased. But try that is not exceed more than 200. So here is we have removed that hairpin, but temperature is too low, and still we have the capacity to add some base pairs. So we can try to add some base pairs like G and T. Analyze result 62%. Okay, so you can now copy it. Hence, your Q gene 01 forward primer and Q gene 01 reverse primer. So for reverse edit, copy and antisense. After preparing or designing the 2 or 3 primers, now we check their specificity to that gene. Either these primers are specific to this gene or they also have some matching sequence of with other genes. So we will blast them in ncbi. So copy it, go to ncbi, click on blast, then you will find this window. So select that nucleotide block, click on it. Here you can paste your sequence, and in the organism select your organism, solanum lactopersicum. Persicum, and show the results in new window and check it. So ncbi give us the blast results. So there are some other copies also have the sequence of this gene. It means that gene is not specific to our desired gene. So we will try to blast that another primer, this one, copy and paste, blast. It is also not specific to that gene. So it means that we need to design other primers. If you try again and did not find the primer in your CPS sequence, then you need to find it from your genomic sequence. But remember that your primers 3 and 5 end of your sense or antisense primer or primer sequences must be from exonic region. Like this genomic sequence contains the exonic sequence as well as the intronic sequence, or coding regions and non-coding regions. These highlighted base pairs are coding regions, while these are the coding regions, while these non-highlighted, these ones are non-coding regions. When you download it from the phytozones, it will come in this shape, and it clearly tells, or through view we predict that which base pair is the coding and which one is the non-coding. So you will try to use this sequence to design this primer. But remember that the one primer, some base pairs like forward primers, base pairs like this have the exonic sequence, while the other also, the reverse primers also have the some sequence of exonic region. So we use this, copy it, that is because it contains all exonic and intronic regions. Copy, open the primer premier, first you delete the sequence, paste, okay, primer, and then here you go to search. Here is also, so our product size is you can say 70 to 200 or 180 ms. Here is okay, and okay. It gives us only 4 paragraphs. So click this. So here also we found some hairpin timer or false priming, so we can edit it. Now we can do analyze. So it's okay, temperature is also okay, and length is 21 is okay. So GC content is also 52%, and hairpin is not found, timer is also not found, false priming is also not found. So it is now good. Now we try to read that sequence, but here we okay. Read. No, so here is a temperature is a little bit high. If temperature is too low, so we can reduce that from here. After deleting every gas pair, you analyze it to check. If gas pairs are too low, so no, it is not. We try another one. We also have this one, so when we click on this camera didn't have the hairpin, and its temperature is a little bit lower, so we will add some base pair to increase its temperature. So edit, and here is the G, so its complementary is C, and analyze it. So its temperature is increased, and hairpin is also not found, and false priming is also enough present, so okay, it is okay. So you can also copy it, sense, and here you the anti-sense, copy anti-sense. Okay. So you have got this primer, and also found design another 2 or 3 primer, and then repeat the process by blast it into ncbi and check its specification for that gene. So in this way, after trying again and again and again, you will get your primer for qPCR which were specific to this gene. The designing the primer for qPCR is taking much more time and full attention. You must give it a special time to design the primer. And then after when you getting your specific primer, then your results must be reliable and good. Hopefully it will help you. Thank you.